This is my prototype of the smart feeder for parallel AC DC reconfigurable links. What this does is that there are several conductors. These are resistances that emulate the conductors, and then you have feeders or several switches, mechanical switches, which can select whether those conductors can run in AC or DC. And then you have some smartness here, right here, and then you can ensure that these conductors are not simultaneously AC or DC, because we don't want that. So yeah, and I use them with my back-to-back converters, and I show that a system with parallel AC-DC links and having this kind of smart reconfigurability can have several advantages, like reducing the investment costs. It can also improve the capacity of the system by downsizing the converter. It can improve the efficiency of the system. It can impact bus transfer uh, between parallel feeders without having a possibility of arcing. So yeah, that's what I'm doing since the last 4 years now.
So the restructuring of medium voltage distribution grids using parallel AC/DC reconfigurable links. Um, what I proposed is that by refurbishing to DC, you can have 50 to 60% higher capacity using the same links, and then between substation A and substation B. And also you can see that there is a AC bypass, the reconfigurability, which can have a better advantage from the purely DC system during n-1 contingencies. And in fact, parallel AC-DC links are also quite quite interesting because they can improve the efficiency of the system. Um, this is in the context of a larger system where there is a radial AC network and you can have a DC embedded DC interlink which can asynchronously mesh the system. And there are several advantages of this system, but I will not go too much in detail about it. So back to the reconfigurability concept, and you can see that there is a DC path and there is a AC path, and I showed you how the smart feeder can achieve that. And then there can be parallel AC/DC path. Of course, you have to make sure that the link conductors are not simultaneously AC and DC, because that's a problem. When you write the system equations for the efficiency, you get some crossover lengths. Of course, if there are, let's say, 9 conductors between two substations, then you can have 3 AC conductors making one three-phase link, and the rest of the conductors are operating in DC. You can have all 9 conductors working in AC, 8 conductors working in DC, and none in AC. So what you see is that parallel AC/DC link, which is this green colored in green color, is in fact can be more efficient than the red color, which is the purely DC link, and blue color, which is purely AC link. Now you can find more information on this in this paper which I'm citing, written by us and recently published. But yeah, it is a very detailed explanation on the economic viability of parallel AC/DC reconfigurable link, sensitivity to voltage, sensitivity to conductor area, and converter efficiency. So yeah, check it out.